Let's have a look at SATA. SATA was released back in the year 2000, so it's been around for a long time. It replaced the earlier PATA standard. PATA used a larger ribbon cable. In contrast, SATA uses a much thinner cable. Due to the size of the PATA cable, it was difficult to work with and blocked airflow inside the computer. The thin SATA cables are easier to work with in comparison. PATA is long obsolete, so don't worry about understanding how it works. I've just shown it to give you an idea of why SATA was developed the way it was. SATA is short for Serial ATA. The ATA part stands for Advanced Technology Attachment. This term dates back to the early days of computing. If you've not guessed it, SATA is serial, while PATA was parallel. With the advancements in data communication, it's become possible to send more data using serial than parallel. Parallel has the problem that when you start speeding the data rate up, it gets harder to keep multiple lines of data in sync with each other. Thus, you can see why serial is used nowadays over parallel. The PATA interface was developed back in the day of slow-moving hard disks. SATA was designed to be compatible with PATA hard disks, but also added improvements. In order to be compatible, SATA supports two modes, IDE and Advanced Host Controller Interface, or AHCI. IDE refers to a popular name used for PATA hard disks in the old days. What you need to know is that IDE, referred to here as native IDE, is the old standard and AHCI is the new standard. You should always use AHCI whenever possible. Given SATA hard disks have been around since the year 2000, it's unlikely nowadays you'll come across a storage device that does not support AHCI. This particular BIOS has the option to set SATA type to native IDE, RAID or AHCI. RAID is used when you want to combine multiple storage devices together, so the operating system sees them as one storage device. In a UEFI setup, you may have these three options. With newer computers, you may find that the IDE option is no longer present. As time goes on, manufacturers are starting to drop support. It's by today's standards very old technology. SATA is much faster than PATA, but there are also other improvements that were made. In order to use these, AHCI needs to be selected. One of the features added is hot swapping. Hot swapping allows a hard disk to be installed or removed while the computer is on. The next big improvement is native queuing. Native queuing means the storage device is able to change the order of the requests it receives. To understand this better, consider that 3 requests are coming in. These requests are colored green, yellow, and orange. Without native queuing, the hard disk does not read the data efficiently. The head of the hard disk will go past blocks it could have read in favor of reading the next block in the queue. Native queuing allows the storage to reorder the requests. The hard disk knows that while it is spinning, it can move the head and read the blocks out of order. This has the advantage that all 3 blocks in this example can be read in one spin of the hard disk rather than 2 spins. Thus, you can see why you would always want to use AHCI. Now, let's look at the next big change in SATA, that is, the cables themselves. SATA uses 2 different cables. The first one that I will look at is the data connector. This is an L-shaped connector, essentially a keyed connector preventing it from being put in upside down. It provides the equivalent of one bidirectional data lane. Given the number of wires in the connector, it's not possible to add any additional data lanes. The next connector is the power connector. This is also an L-shaped connector. As before, a keyed connector like this prevents the connector being put in upside down. The connector itself supports 3 different voltages, these being 3.3, 5, and 12 volts. You don't need to remember these voltages, but you will eventually start remembering them because these are pretty common voltages in a computer system. To demonstrate how to use these cables, I have a motherboard and a hard disk that I will connect together. To start with, I will first plug in the SATA drive cable. You'll notice the L-shaped connector. In order to plug the connector in, I will need to locate a SATA connector on the motherboard. Your motherboard will most likely have a few of them. You'll notice the L-shaped connector prevents the data cable being put in upside down. The cable needs to be pushed into the connector on the motherboard. You should hear it click into place. The same applies for the hard disk. Push the other end of the connector into the connector on the hard disk until you hear it click. To remove the connector, in some cases, you can just simply pull the cable out of the connector. In this case, this cable has a latch on the connector. In order to remove the connector, the latch needs to be pushed down. In most cases, the connector will go in without pushing down on the latch. With some cables, the latch will make it difficult to push the connector in. So if you are having problems getting the connector in, push down on the latch and try again. Some SATA cables will have a latch and others will not. You may be tempted when doing maintenance to pull on the cable to remove it. However, if the cable has a latch, you won't be able to pull the cable out. If you look at the other end of the cable, if it has a latch, the other end probably has a latch as well. If you pull a cable that's connected with a latch, you risk causing damage to the connector. If you damage a connector on a storage device, this may mean you will need to replace the circuit board on the storage device. In some cases, this may work. In other cases, it may work, but you will lose all the data on that storage device. The next step is to plug in the SATA power connector. As before, the SATA connector is an L-shaped connector, so in order to plug it in, you just need to make sure that it's up the right way. That's really all there is to it for plugging the connectors in. The computer's off at the moment, but I have plugged the hard disk in while the computer was on. Let's have a closer look at how the connectors support hot swapping. SATA facilitates hot swapping at the hardware level, allowing storage devices to be connected and disconnected while the computer is operational. However, there is a risk associated with hot swapping. The risk occurs when the device is plugged in or unplugged, as a power surge occurs during the connection or disconnection could potentially damage the storage device, with the highest risk occurring when the device is initially plugged in. In order to prevent this from occurring, the pins on both the SATA connectors are staggered. When the connector is inserted, the outer pins make contact first. These pins are linked to components designed to dissipate any excess power. The inner connectors then establish a connection. These inner connectors aren't required to have surge protection capabilities. While the difference between the outer and inner pins might seem minimal, this small gap is sufficient for the electronics to stabilize the power connectors by drawing off any excess energy. Newer computers will have plenty of SATA power connectors as the standard connection. In some cases, you may start running out of connectors. Let's have a look at an option you can use if you do start running out of connectors. If you're running out of connectors and you have free Molex connectors, you can use a SATA to Molex connector. This converts the Molex power connector to a SATA power connector. It's important to be aware that if you use this connector, it does not include a 3.3 voltage. On the positive side, not many storage devices use this voltage. If it is used, it tends to be used for enterprise storage devices. In later versions of SATA, there was a feature added that allows a hard reset of the hard disk to be performed. This is an optional feature that does not use the 3.3 volt wires. You don't see it used much, once again most likely used if you have enterprise storage devices. This won't present a problem with newer equipment. However, if you do use these storage devices with older equipment, they may not work. Now that we've had a look at the cables, let's have a look at the different versions of SATA. There are currently 3 different versions of SATA. SATA version 3 was released in 2008 and thus a long time ago in the world of computing. This means nowadays you're most likely to come across SATA 3. The good news with SATA is that all versions of SATA use the same cables and connections. Thus your old SATA cables will still work, even if they were manufactured before SATA 3 was released. I wouldn't worry about remembering too much about the earlier versions of SATA. The main takeaway I think is important to keep in mind is that the speed of SATA 3 is 600 megabytes per second. With storage devices getting faster and faster, there are devices that are able to transfer data faster than this. SATA is thus limited to what devices it can be used with if you want to get the best performance possible. Later in this video, I will look into this in more detail. There have also been minor updates to each of the main versions, added performance and bug fixes. At the time this video was made, the last version update was released in 2020. Thus, it may be worthwhile checking your storage devices and updating your equipment to the latest firmware to take advantage of these fixes. However, don't expect too much of a performance increase. A lot of the updates are minor in nature, although everything helps, and it's doubtful in most circumstances you'd notice any difference. Due to the technology and flash improving, minor updates in SATA won't help you much in performance terms. To understand why, let's have a look at how solid-state drives were first introduced to the market. The first solid-state drives introduced to the market used the same interface as SATA. This made sense since everybody already had SATA hard disks, and thus to make the changes, you could use your existing hardware. SATA was originally designed with hard disks in mind. Hard disks have one moving arm, so the protocol was designed with that in mind. Back then, it was not really a problem because flash was not that fast. Nowhere near as fast as it is today. SATA solid-state drives can also use the M.2 form factor. Essentially, the underlying protocol used is the same. Just the package it is delivered in has changed. Using the M.2 form factor means the storage is smaller and thus costs less to manufacture. It's also possible to get an enclosure like this one. These enclosures are designed for an M.2 solid-state SATA drive to be put inside. Basically, it looks just like the solid-state drive that we just looked at. However, it will have an M.2 solid-state drive inside. If I were to try and predict the future, I would say that manufacturers will stop producing the traditional solid-state SATA drive and sell you an enclosure with an M.2 solid-state drive instead. There are currently two different types of M.2 storage devices currently sold on the market. These are SATA and NVMe. The solid-state drive has a notch missing at the top. The position of this notch corresponds to a specific letter designation. In the case of SATA, the notch position is in what is referred to as B key. Although it's technically possible to have a solid-state drive with only a single notch for SATA, we find in the marketplace this does not occur. Instead, there's often a second notch missing. This is located at the bottom and is referred to as M key. M key is used for NVMe or non-volatile memory express. NVMe is a replacement for the SATA protocol. Later in the video, I will have a little bit of a look into NVMe. However, full details of NVMe I will leave to another video. Although this solid-state drive only supports SATA, it also has the M key notch, so it can also be used in M key slot motherboards. Some M.2 M key slots on a motherboard will support SATA and NVMe. In order to use SATA, it doesn't matter if the M key notch is present or not. However, not having this present would reduce the number of motherboards the storage could be used in, since the storage could not be used in M key slots that support SATA. Thus, all SATA M.2 storage devices that I have ever seen have the B and the M key notches. Thus, if you see both notches missing, it's safe to assume it is SATA. You'll often hear this referred to as a B plus M key. To put it simply, if you ever see B key or B plus M key mentioned, it's referring to SATA. It appears that the market is moving slowly towards M.2 SATA rather than larger solid-state drives. SATA won't disappear anytime soon, and later in the video I will look at the reasons why. Before that, I will have a look at some of the SATA interfaces that have not been that successful in the market. I will next look at the SATA Express connector. This connector allows the use of two lanes rather than just the one lane. This connector never really took off, so it's very doubtful you'll be asked a question on it in the exam. And you don't really need to know about it. The only reason I mention it is, if you're working on an old system and see it, you'll know what it is. The connector itself looks like two SATA connectors with an extra connector to the left of it. The left part is an extra connector for control signals. Since PCI Express is being used to transfer data, some extra wires are needed to transfer the PCI Express control information. To the right of this are two SATA connectors. When these two connectors are used together with the control connector, this is where SATA Express gets two lanes from. In order to use it, a special connector is required. You can see that it's divided up into one control cable and two data cables. In order to use the PCI Express connector, you need a device that supports it. Although you can get a lot of speed out of a PCI Express connector, after it was created, competing products like USB 3 were released. Technology like USB 3 is simpler to use, and thus you can understand why this connector did not take off. If your motherboard supports this connector, you have the option to use two connectors as standard SATA connectors. So far, I've only looked at using SATA for internal connectors. I will next have a look at what you can do if you want to connect an external hard disk. It's possible to connect an external hard disk to a computer using eSATA. eSATA was released in 2004 and provided a way to connect an external hard disk to a computer. It uses a non-powered connector, and thus the external hard disk requires its own power supply. In this example, I have an external hard disk enclosure with a hard disk in it. You'll notice on the back of the enclosure the connectors that it has available. In this particular case, it has an eSATA connector, which is the one that we're interested in. An eSATA cable is not the same as a SATA cable. When I compared a SATA and eSATA cable, the SATA cable is the blue cable and the eSATA is the red cable. You will also notice that the end of the eSATA connector is a little longer than the SATA connector. Notice the end of the connector is different as well. The eSATA connector is not an L-shaped connector. The connector, however, is keyed, so that means that you won't be able to plug it in the wrong way. There's also another difference between the SATA and eSATA cables. You'll notice that the SATA cable is quite thin and also pretty flexible. This makes SATA cables easy to work with. eSATA cables are thicker and not as flexible, making them harder to work with. At the time, eSATA allowed you to access external storage at the same speed as SATA would allow. However, as other technologies developed like USB and Thunderbolt, it became simpler for a user to use this other technology rather than using eSATA. Thus, eSATA is not really used because there are simpler and easier alternatives available that offer better speed. If your computer has an eSATA connection, it will look something like this. These connections are generally found more often on laptops, but due to the decline in use, you don't tend to find them on laptops nowadays. In some cases, the eSATA connection may also be used as a USB connection, which is the case in this example. Simply plug an eSATA or USB connection in, and the laptop will work out which to use. Now that we have an understanding of how SATA works, let's have a look at how to configure SATA on your computer. To configure basic SATA settings on the computer, first of all I need to enter the computer's setup. On this computer I need to press F2 or delete when the computer starts up. In this case, the basic setup screen will be shown. Your BIOS or UEFI setup may look different. Somewhere on the initial screen or a summary screen there will be a list of the storage devices that have been detected. In this case, 3 hard disks have been detected, which I can see at the bottom left of the screen. This screen does not have too many options and is more for displaying information. If you're having problems with the storage device, have a look at this screen and make sure it's being detected. To access more options, I will select the option at the top right, Advanced Mode. This screen will allow you to configure a lot more options than the basic screen. In this case, I want to configure the SATA options. On this computer, the SATA options are found under Advanced. To access the SATA options, I next need to select Storage Configuration. The first option enables or disables the SATA controller. In the vast majority of cases, this will be enabled. It may be disabled for secure kiosks where SATA storage is not being used to make it harder to hack into the computer. These requirements are rare, so more than likely it's going to be enabled. Other than security reasons, there's no real reason to disable it. Following this is SATA mode selection, currently set to AHCI. You'll notice the older IDE option for compatibility is not available in this setup. In some setups, you may need to enable some compatibility options in order to get to the IDE option, or in new computers, it may not be available. Unless you have good reason to, you should leave this on the AHCI setting. If you do decide to change this option, you may need to reinstall Windows or perform a workaround in order to get Windows to boot again. ACHI was released in 2004, so it's well supported. The next option is SATA Aggressive Link Power Management. This provides a different method for the computer to shut the storage device down when it's not being used. If you want to save more power, then you may want to enable this. If you find your system is becoming unstable or you're having problems with the storage device, then disable it. On old hard disks, this option can cause problems. Following this option, the option for Smart allows the computer to get statistics from the storage device. This is found on some hard disks and most solid-state drives. If you were to disable it, it would probably be for security reasons. However, it would be rare to want to do this even in a secure environment. Smart allows software to get information such as how many times the storage device has been switched on and expected life left, etc. It's up to the manufacturer to decide which options they'll implement and which not. The next option is the M.2 SATA switch. Essentially, this motherboard supports 6 SATA storage devices. There are 6 SATA connectors on the motherboard and 2 M.2 connectors. When you install an M.2 solid-state drive, one of the SATA connectors is lost. For M.2 slot 1, the computer can choose between connectors 4 and 5 to be disabled. Different motherboards will function in different ways. Some motherboards will also disable certain connections. For example, if you install M.2 Wi-Fi, when you only have a few storage devices, hopefully you choose the right connections and you won't have any problems. When you get close to maximum, keep in mind that you may reach the maximum before you use up all your connectors or slots. When this occurs, you'll need to decide which ones you want to use. This setup has the option to force a SATA storage device to be used, or force M.2 to be used. Thus, if you find that you add a storage device and it disables one of your existing storage devices, setting this option will allow you to decide which one you want to use. Notice at the bottom, the 3 hard disks that I have installed in this computer are being displayed. This is essentially displaying the same information from the first setup screen. I will now select the first hard disk, which will allow me to configure options for that hard disk. The first option is External SATA. This is essentially eSATA. If I enable this option, notice the option below it for hot swapping is removed. eSATA by design supports hot swapping. What's different between the two is what kinds of messages the motherboard sends to the operating system when a storage device is disconnected. On this particular motherboard, when external SATA is enabled, the connector will change to SATA 2, which results in a speed drop. Although eSATA does support SATA 3, on this motherboard it does not. So since this motherboard supports USB 3, I'd personally use USB 3 rather than eSATA. USB 3 is easy to use and faster than SATA 2. You can see why eSATA did not really take off. Once I disabled this setting, notice that the hot plug option is available. If you're planning on using hot swapping, make sure that it is enabled in the computer's setup. The last option is SATA device type, which allows you to set the option to hard disk drive or solid state drive. This option essentially changes the optimization for hard disks or solid state drives. I'd be surprised if having this set incorrectly causes a storage device to not work correctly. It's more about optimization of the device you've installed. Having said that, the optimization is minor and won't make too much of a difference to the performance of the computer. Now that we've had a good look at SATA, I will now have a look at the future of SATA. When looking at the future of SATA, the first thing to consider is, will there be a version 4? The answer to that is nope. The organization that manages SATA has stated there will not be a version 4 of SATA. The reason behind this is that in order to get higher speeds, this would require too many changes to the way data is sent over the SATA cable. Changes would include changing the voltage and signaling in the cable, which would cause compatibility problems with older devices. Thus, we'll only see updates to the SATA protocol, but we won't be seeing a version 4. We're seeing a trend towards NVMe drives. In the old days, flash memory provided similar performance to that of hard disks. Flash memory has improved and can now support features like parallel reading and writing. A hard disk can only perform one read or write at once, which is a limitation of having one hard disk head. Flash memory, by virtue of having multiple chips and using cache, can perform parallel reads and writes. The problem with this is the ACHI protocol does not support parallel I/O. Thus, if you use SATA with M.2, you're going to be limited to what the ACHI protocol allows. To understand how NVMe achieves this, consider that SATA has one queue which has a maximum of 32 commands. As we learned earlier, SATA has the ability to process these commands out of order. but that can only achieve so much. NVMe, in contrast, supports over 65,000 queues with over 65,000 commands per queue. Having so many queues and so many commands per queue allows the storage device to make a lot of optimization decisions about how it will read and write data. Having multiple queues allows the storage device to work in parallel. You can see why, from a performance perspective, SATA 3 has reached the peak of what it can achieve. However, there is one big limitation of NVMe. Pretty much the only big advantage that SATA has over M.2 is hot swapping. If you do come across SATA being used for hot swapping, it will most likely be with removable drive bays like this one. A removable drive bay allows you to plug a hard disk into the bay. Essentially, the drive bay provides a SATA connection to the hard drive. Once the hard disk is ready, I'll next put the drive bay into the computer. Since SATA supports hot swapping, this can be done while the computer is on. If this doesn't work, make sure hot swapping is enabled in your BIOS or your UEFI setup. Keep in mind, the operating system also needs to support it, which modern operating systems should. Notice that the hard disk can be removed at any time. In order to use a hard disk enclosure like this one, it needs to be installed in the computer. Depending on the enclosure, sometimes, if you don't push the drive in hard enough, it won't connect. Given you can purchase almost an endless number of USB and Thunderbolt external hard disks, you can see why enclosures like this one are not used that much nowadays. You can even purchase an external USB enclosure, which works in a similar way to this enclosure but for USB. Thus, you can see, even though it's useful to have hot swapping, in the real world, it doesn't get used that often. Despite advancements in storage speed and the emergence of technologies poised to replace SATA, there remains one big reason why I believe SATA will continue to persist for some time. The main reason I think that we'll see SATA around for a while is that it's relatively cheap to add it to a computer. To understand why, consider that you have your CPU. If you want to get the best performance, you want to connect your M.2 NVMe solid-state drive directly to the CPU. It's possible to connect M.2 to other chips on the motherboard, but in this example, we're talking about trying to get the best performance you can. Thus, you want a direct connection to the CPU. In order to make the connection, the M.2 device may utilize up to 4 PCI Express lanes. A PCI Express lane is essentially a data channel that provides high-speed transfers between devices, in most cases directly to the CPU, but in some rare cases, from other chips. SATA does not require the high speed of PCI Express and is relatively quite slow. Because it does not need to be as fast, SATA is often put on the south bridge of the computer. The south bridge is essentially a chip on the motherboard that handles devices in the computer that do not need direct access to the CPU. In order for the south bridge to communicate with the CPU, it does this using a PCI Express lane. So essentially, we have the CPU handling high-speed devices and the south bridge handling low-speed devices. If we want to have 6 SATA devices on the computer, we simply need 6 SATA connections from the south bridge. Although SATA and PCI Express use different types of signaling, you still need the same basic number of wires on the motherboard for each. Thus, for the 4 lanes we used for one M.2 device, we could have the equivalent of 4 SATA devices. Thus, you can see from an engineering point of view, it's much cheaper to add SATA ports to a computer. Firstly, you don't need to connect it directly to the CPU. Each device connected to the CPU means more pins on the CPU, making it expensive to add devices. Secondly, only requiring the equivalent of one low-speed lane makes it cheaper to implement. Thus, the main takeaway from this is, it doesn't cost the manufacturer a lot of money to have a few SATA ports on their motherboards. Motherboard manufacturers don't like adding things that are not needed, so as to keep the costs down. But if it doesn't cost much to start with, and maybe the difference between a sale and not a sale, they're going to add it. It's all about costs and sales at the end of the day. You can see why I don't think SATA will disappear anytime soon. It doesn't cost too much to add a number of SATA ports to a motherboard, and there's still a lot of devices on the market that will use them. SATA is also still the primary connection used for hard disks. At the time this video was made, the fastest hard disk in the world was just over 500 megabytes per second, still under SATA's 600 megabytes per second limit. There's been a lot covered in this video, so let's have a look at how you would use SATA in the real world. In the real world, SATA for the moment is here to stay. There'll be no SATA version 4, so SATA 3 will have to do until we need something better. For the future, the main use of SATA will be for hard disks. Since hard disk storage is getting bigger and bigger, the main use of SATA will be for utilizing hard disks as mass storage. M.2 we are seeing used for fast storage. Fast storage is utilized for the operating system and small amounts of data. If the storage needs are not too great, we are seeing computers with only an M.2 storage device and no hard disks. This has become very common in laptops, to the point where some laptop manufacturers are no longer selling laptops with hard disks. With the use of M.2, we are seeing a big decline in the manufacturing of SATA solid-state drives. These devices have essentially been replaced by M.2 storage devices. The only disadvantage of doing this is that M.2 does not support hot swapping. Given the increased speed and availability of USB and Thunderbolt drives, most users will use these if they require hot swapping. If you're going to install an M.2, NVMe is faster than SATA and has improvements in the protocol that SATA does not have. This is because SATA was designed with hard disks in mind. In order to determine if an M.2 solid-state drive is SATA or NVMe, have a look at how many notches are missing. SATA will have 2 notches missing and NVMe will have 1. NVMe refers to the interface specifications used to access the solid-state drive. The connection to the drive is PCI Express, so NVMe and PCI Express may get used interchangeably. If you hear either of these names, you know they're talking about the same thing. If you hear SATA used, you know they're only referring to SATA. That covers it for SATA. I hope you found this video useful and informative. Until the next video from us, I would like to thank you for watching.